Okay, sorry. Okay. So today I'm going to present the paper about this reassessment of Crossrail excavation case history by the Ab initio Approach A from the new observational method framework. And this paper was jointly done by me and my supervisor, Giovanna Bisconti, and Mr. Duncan Nicholson from of Europe. So in my presentation, I will firstly brief the background of the observational method and introduce a new observational method framework. After that, I will use a Crossrail excavation case study to demonstrate the different design between the original design, as-built modified design, and the reassessment design carried out by Ab initio Approach A, and that will try to demonstrate how the Ab initio Approach A can maximize the cost saving in the design, and the last will be the conclusion. So very shortly, for the observational method, it's initiated from early engineering practice, and Carl Tasaki summarized this as a learn-as-you-go method. But by 1969, in the ninth ranking lecture, Professor Peck formulated this observational method with two design approach. The first is ab initio, means apply the observational method from beginning, and that will use most probable design parameters under the most probable design conditions. And the second approach is the best way out that's proposed for some unexpected events already happened or going to happen. So it's aiming to use the observational method to save the project from the difficult situations. After that, the observational method have been applied in the practice, but it's neither the ab initio approach or best way out approach. It's developed as a progressive modification approach. So those new development has been discussed and summarized in the Ciria report 185. That's the observational method in engineering and in ground engineering. In this Ciria report, the observational method was definition was defined, and other than the ab initio by Peck, this report recommend a cautious ab initio, which means the design with the characteristic parameters under the cautious design conditions, and it's not mentioned about the best way out approach in this report. And since 2000, this observational method has been accepted by the design code, such as Ciria C760 and Euro design code. So even with the obvious benefits of observational method, it has demonstrated lots of saving has been saved from the project to use the observational method. However, there are lots of uncertainties still remain in the observational method, which such as uncertainties deriving the values for the design parameters. For example, what's the characteristic parameter? What's the most probable parameters? I think people still got lots of argument about this definition, and also the difficulty created by the observational method in the contract has stopped people using the observational method. And now a new observational method framework has been proposed. It's trying to use this new framework to classify the different approach, try to clarify the design parameters used for the different approach, and this is aiming to help to promote the application of the observational method. So in the new framework, there are two big branches. One is ab initio, another is Ipso tempore. It's just opposite to the ab initio, means start from beginning. Ipso tempore just try to apply the observational method at the moment, which means after construction, you still try to use it. So under the ab initio, we got ab initio Approach A is more like the Peck's ab initio approach, which means the design planned with most probable parameters in parallel, we prepared a contingency plan. It's designed by the characteristic parameters under the cautious condition. And this approach B, cautious approach B, is similar as the cautious ab initio recommended in the Ciria report 185, which means the design starts with the characteristic parameters, but a modified design is prepared with most probable parameters, which means when the condition is right, we can just switch to the modification design. Under the Ipso tempore, the approach C, proactive, is newly defined, which means when construction started and all the observations showing the performance is much better than the prediction, then we can try to back analyze the early construction stage and develop a modification plan. But for the approach D, that's similar as PAC's best way out. It's just try to save the project from the difficult situations. So with this new framework, this full design approach is managed to classify all the case history have ever used the observational method. And here we got some excavation examples from Crossrail projects. So we can see these 4 station excavation have successfully used the observational method, achieved savings, is either in construction program or the material saving. And the approach B to approach D managed to classify all these 4 case histories. Now let's focus on the first case. Is a Tottenham Court Road Station, Western Ticket Hall. This deep box is about 31 meter by 41 meter. The location is at the center of London, and the excavation is in the typical London clay material. And here is a layout of this case. So basically, we can say this deep box is next to the Oxford Street, which is one of the busiest roads in London. And the excavation depth is about 30 meters deep. So in order to enable this deep excavation, the original design have proposed a 1 meter thick duffel moor. And on the graph, this cross-section AA has shown the 5 levels of temporary props that has been required to enable this bottom-up excavation construction. And here we got the layout plan for the instrumentation and monitoring plan. Initially, this intensive monitoring plan was developed is for the asset protection, but thanks to this intensive monitoring plan, we got lots of monitoring data, which make the back analysis is possible and enables the modification design. So look at this layout of instrumentation. The major instrumentation include inclinometers. In this case, it has used a shape arrow axle. It's more like an in-place inclinometer, in-place type of inclinometers to measure the wall deflections. And it also have the vibrating strain gauge installed on the temporary props to monitoring the temporary prop force. Also, piezometers and extensometers installed inside of excavation box to monitor the change of the poured pressure and vertical movement of the ground surface during the excavation. Other than that, there are additional prisms installed at the cabin beam levels and first levels of the temporary props to measure the structural movement. We also got a lot of leveling studs installed on the road to measure the ground surface settlement during the excavation. So thanks to all this intensive data, then we managed to do a back analysis during the excavation, and the set of most probable parameters were calibrated from the back analysis and developed the modified approach C design is the as-built design. So as shown on the graph, which managed to omit the lowest level of the props and save the 4 weeks of construction time. And the total cost of saving is £715,000, which is equivalent to about 14% of the total construction cost for the excavation construction. And here is the back analysis was carried out for this modification plan. So on the left-hand side is the stage where the back analysis was carried out. So it's not just validated as the most probable conditions as a total stress analysis. Even though we can see at this early stage the prediction by total stress analysis and mixed earth pressure analysis, it doesn't really show much difference. But with the excavation depth increase, this difference make much. This difference is became more significant, and we know from the monitoring data, it doesn't really show that much of movement. So we know the total stress is probably more like a most likely condition for this excavation construction. And but I think the interesting thing was that when I started my research, I reviewed all the monitoring data, and I find out is in the SAA row data, there are a kind of a rotational arrow in the data, which means, for example, if the SAA segment is rotated from point A to B, it doesn't really change the tilting angle is measured from the SAA, but it will significantly change the distribution at x-axis and the y-axis. And I thought that's probably the reason the SAA data showing some unusual change at a certain point. So I did the correction. Try to eliminate this rotational arrow in the SAA row data. And this is at the final excavation stage. It's showing the corrected SAA data has been reduced, the maximum wall deflection from the row data about 22 millimeter, reduced down to about 15 millimeters, which means the most probable parameters calibrated from the back analysis probably is not really accurate, and it's necessary to carry out another back analysis based on this corrected SAA data. And I did this back analysis, and this is a prediction from the back analysis, the black dotted line, and we can see it matches with the corrected SAA data very well. And this also provided me updated most probable parameters from the back analysis. And use this updated most probable parameters, I managed to carry out a reassessment of this deep box excavation design by the Ab initio approach A. So basically, they are using the same semi-fine element analysis program and using the more column soil model. And in order to keep things more comparable, I try to not change too much about the design, so it's only the wall thickness has been changed from 1 meter thick to 800 millimeter thick for the reassessment design. And for the design condition, as I mentioned earlier, so on the left-hand side is the total stress analysis as the most probable condition is assumed for the most probable design. On the left-hand side is the mixed earth pressure design condition was assumed for as a cautious condition for the contingency plan. And that's showing the difference, because total stress analysis will only need 4 levels of temporary props in order to support this deep excavation. But for the mixed earth pressure design, we will need at least 6 levels of prop to support this excavation. So after clarified that, then this is calculation results of the bending moment envelope from the ultimate limit states calculation. And we can see the ab initio approach A reassessment, the bending moment envelope, the black line is by the most probable design, and the orange line is by the contingency plan. They all below the reinforcement capacity for the 800 millimeter wall. That's a red line, and these are already updated compared to the original 1 meter thick wall reinforcement. And here is the wall deflection under the service limited state calculation, and these are required for the construction control. So as far as the reassessment by the ab initio approach A design is well below the red triggers defined by the project, I think the design is safe. And here I present a summary of the cost comparison. So as we know from the case history briefing, the as-built modified design, the approach C design, is managed to save about 14% of the total construction cost, total cost of the construction. But if we able to adopt the ab initio approach A design, it will provide us more than 25% of saving in the construction material, and potentially it can also achieve some saving in the construction time. So it's quite obvious if we are be able to use ab initio approach A from the new observational method framework, the cost saving in the construction materials will be maximized. But there is a potential risk. We might risk to prolong the construction time, and that will really depend on the project requirement if we can do this or not. Sorry. Yeah. So, this is just my conclusion of this reassessment. So basically, the back analysis is the key of the observational method, but a good back analysis depends on the reliable observation, and there is necessary to improve the quality of the monitoring data that include a better specification and execution of the installation of these instruments, and review the monitoring data properly. And the last one is the ab initio approach A. It's showing it can magnificently saving the construction cost. Thank you.